Hello there, and welcome. So, have you ever been in a movie theater trying to find your seat? Or maybe you're looking at a subway map trying to figure out where to go. To find any place, you need to know exactly where it is. And today, we're going to learn how math helps us do just that. Think about it. Any map you've ever used has a secret system for telling you where things are. Well, it's not really a secret. It's just math. And today, we're going to learn that system. We're going to see how a few simple numbers can help us find any place we want to go. So, here is our plan for today. First, we'll figure out what a coordinate is. Then, we'll learn how to draw on a flat surface, which we call a plane. After that, we'll see how graphs tell a story. And finally, we'll look at two cool patterns, direct proportion and inverse proportion. Don't worry, we'll go step by step. It's going to be fun. All right, first up, what in the world is a coordinate? Well, let's start with the simplest map you can possibly imagine, just one single straight line. This is a number line. You've probably seen this before. Right in the middle, we have 0. If you go to the right, the numbers get bigger, 1, 2, 3, and so on. And if you go to the left, they get smaller, -1, -2, -3. Now we can put points on this line. Think of the line like a street, and each point has its very own address. In math, we have a special name for that address. We call it a coordinate. The coordinate is just the number that tells you the point's exact location. So look at point A. Where is it? It's right on -3. So the coordinate for A is -3. And we write it like this, a capital A, and then the number in parentheses right next to it, A -3. Okay, your turn. Take a good look at that number line again. What do you think the coordinate for point B is? I'll give you a second. Okay, your turn. Take a good look at that number line again. What do you think the coordinate for point B is? I'll give you a second. Did you say 4? If you did, you're absolutely right. We write it as B4. See, you're already a pro at this. That was pretty easy, right? But let's be real. A map isn't just one single line. A map is a whole flat page. So to find a spot on a flat page, we're going to need 2 lines. So here's what we do. We take 2 number lines. The first one goes side to side, horizontally. We called this one the x-axis. The second line goes straight up and down. That's our vertical line. We call that the y-axis. And see where they cross? Right in the middle? That special meeting point is called the origin. Now, on this new 2-line map, every address needs 2 numbers. We write them inside parentheses, just like this, x, y. This is called an ordered pair, and the name is a huge hint because the order is super, super important. The first number is always for the x-axis, the side-to-side one. The second number is always for the y-axis, the up and down one. Always remember, x comes first. Let's try to find a point together. How would we find P of 3, 2? Well, first we always start at the origin, right there in the middle at 0, 0. Okay, the first number is 3. That's our x number. So we move 3 steps to the right. 1, 2, 3. Great. The second number is 2. That's our y number. So from where we are, we move 2 steps up. 1, 2. And that's it. We put a dot right there. That's our point, P3, 2. So why are we doing all this? Why are we putting all these little dots on a plane? Because, and this is the cool part, we can connect them to make a picture. And a picture made out of numbers can actually tell a story. We call this kind of picture a graph. Let's imagine you're growing a tomato plant. Every week, you take out a ruler and measure how tall it is. You could write all this information down in a table, just like this one. So at week 0, when you just got it, it's 2 centimeters tall. After 1 week, it's grown to 4 centimeters. You see, this table shows us the relationship between time and height. Now we can take all those numbers from our table and turn them into a picture. And that picture is our graph. A graph just uses points and lines to show us how 2 things are connected. In this case, it's connecting the time that's passed with the height of our little plant. So let's do it. Our first ordered pair from the table is 0, 2. The next one is 1, 4, and then 2, 5. We'll put all of these points onto our plane. Now for the fun part. Let's connect them with a line. And look at that. You can actually see the story now. That line is going up and up. It's a picture of our plant growing taller every week. How cool is that? Sometimes these graphs show us really clear patterns. Let's check out the first one. It's called direct proportion. Now that sounds fancy, but it's a super simple idea. It's just the more means more pattern. When one thing goes up, the other thing goes up right along with it. Think about filling a swimming pool. After 1 hour, maybe the water's 3 centimeters deep. So what do you think happens after 2 hours? Yep, it'll be 6 centimeters. And after 3 hours, 9 centimeters. You see the pattern, right? As the time gets bigger, the water level gets bigger in a really steady, predictable way. This steady relationship is what we call direct proportion. When x gets bigger, y gets bigger too. So if you double x, y doubles. If you triple x, y triples. It's that simple. And here's a hint. The graph for direct proportion is always a perfectly straight line that goes right through the origin, 0, 0. And of course, there's a little math rule for this. It's just y equals a times x. That a is just a number that stays the same. For our swimming pool, the rule was y equals 3x, because the height was always exactly 3 times the number of hours. All right, we're on to our last big idea for today. If direct proportion is the more means more pattern, what do you think inverse proportion is? You probably guessed it, it's the more means less pattern. Let's imagine you're driving to your grandma's house and it's 120 kilometers away. If you drive really, really slowly, like 10 kilometers an hour, it's going to take you 12 hours. But what if you drive faster, say 20 kilometers an hour? Now it only takes 6 hours. See, the faster you go, the less time it takes. This is inverse proportion. When x gets bigger, y gets smaller. For instance, when you doubled your speed from 10 to 20, the time was cut in half, from 12 hours to 6. And check out the graph. It's definitely not a straight line this time. It's this really cool smooth curve. And you know this pattern has a rule, too. It's y equals a divided by x. For our car trip, the rule was y equals 120 divided by x. The time it took was always just 120 divided by whatever our speed was. Wow, we have covered a lot of ground today. Let's do a quick recap of the main ideas. First, a coordinate like x, y is just an address for a point. Second, a graph is a picture that tells a story with numbers. Third, direct proportion is more means more, and its graph is a straight line. And fourth, inverse proportion is more means less, and its graph is a curved line. You did an amazing job. And that's pretty much it for today. But before you go, I want to leave you with a question. Think about your own life. Maybe it's the number of hours you practice a video game and your high score, or how much money you save each week. What story from your life could you tell with a graph? Thanks so much for learning with me today.